Hey, my name is Connor Casarda. I am a computer science major and a math minor, also getting a certificate in cybersecurity. I'm currently a junior, and as a hobby, I like to do 3D printing. So in the Makerspace, I help out with 3D printing the face masks and the face shields. But at the same time, I've been thinking about how can these current designs be improved? How can they be made safer for the person using them? And one of the other aspects we've been looking at is how can we more safely secure the filter to the mask? So on the side of 3D printing, I've also been working on prototyping a few of these designs. And usually what I do when I prototype something like this is first I just sketch it in a notebook. I just draw a few designs, and then when I pick out a few that I think would work out really well, I take those to CAD software. And CAD stands for Computer Aided Design. And it's any program that allows you to turn a design or something you're thinking about into a digital 3D model. And yeah, and then basically once you create the model the 3D model that you want, you can take that from your CAD software, and then what I do next is I take it to something called slicing software. And this is really important for 3D printing because essentially what slicing software does, like the program Cura that we use, it takes a digital 3D object that you've created using the CAD software, and then it converts it into something that the 3D printer can understand. So what temperature the heat bed needs to be, or the nozzle, what kind of plastic is being used as well. And so all those details go into something called G-code. So the 3D object from your CAD software goes into the slicing software, and then it becomes G-code. And then once we get the G-code, we take that, we put it on a USB or a flash drive or an SD card, and then we put it in the printer, and then we just print it out. And usually it takes, the one design we've been working on or finally decided to print, it took about a few hours or so. And then essentially what we're gonna do is once it prints out, we're gonna remove it from the printer and test it out, see how it works. Try and keep the things that worked out really well, try and remove and improve the things that didn't work out well. And of course, prototyping it's just a long cycle of trying it over and over again, trial and error. And yeah, so the first thing I can do is I can show you the CAD designs that I've worked on. All right, so this is the CAD software that I like to use when I prototype. And it's a program called Fusion 360. And so since I'm currently a student, I'm able to use it for free through an educational license, which is great. And right now, we're looking at the first design that we came up with. And these designs, I should note at first that these designs are based off a mask 3D model that was created by a dentistry group in Billings, Montana. And it's a really popular mask that's been 3D printed by a lot of people. And these are actually the masks that we're 3D printing at the moment. But right now, this is a adjusted design that we came up with in this CAD software. And it's as simple as making the filter so that instead of it just being inserted through the, I guess you could say the mouthpiece and just sitting there, it's made more secure in such that you can just slide the filter in through the top, just like this, through an opening on the top of the mask. And yeah, so this was the first design we came up with. However, we ran into a problem where this would actually require supports to 3D print it, and I'll show you what I mean. So I'll make the filter part invisible for a moment. So if we look here, this is how the mask would print on the print bed. But there's an issue where we actually have a huge overhang here where I'm selecting. And this would not be able to print successfully because you need something underneath to print on, or a layer underneath to print on, for it to be successful. And you can only have an overhang of about 45 degrees for it to be successful, which is why this component, these components here are able to print successfully, but not, of course, not something like this. So we had to go back to the drawing board, and this was the second design we came up with. So instead of inserting through the top, we put the filter in like normal, but we created an extra component here, highlighted in blue, where you just take it, and it has tabs on the side, and on the mask there are empty slots here where I'm selecting. And basically, you just click it into place, and that secures the filter in there. And when I took this design to a few people in the Makerspace, they really liked it, so we decided to take it, convert it to G-code through the Cura slicing software, and then 3D print it. So what I can show you next is the 3D printing process. All right, so here we are. This is the part where we start to 3D print the component that we created, first in the CAD software. And then after that, we took it to the slicing software so that it could be converted into G-code, again, which is something that the 3D printer can understand. And then we take that G-code, put it onto an SD card, and then into the 3D printer. So this is just a clip of it printing partway. It's printing the mask, the filter part, and then the extra component that we added. All the stuff that we did in CAD is being printed here. And then once it's done, we'll take it off and we'll test it, see what worked out really well and what didn't, and then we'll just start the process all over again. Cool, so we looked at the prototyping process, and in doing so, we also got to look at CAD software and the 3D printing. So if you have any questions, feel free to email me. My email is ccasarda, so CKASARDA @uyo.edu.
My name's Victoria Evans. I'm a sophomore, pre-pharmacy major. I work in the Student Innovation Center in the new engineering building next to the STEM building. I'm the vice president of the club there, which is really fun. And today I just figured I'd talk about what life is like over in that makerspace and how you can get involved. So a normal day in the makerspace is actually really hard to predict because we're doing like different things every day. When I came back from Christmas break, the project that I decided to tackle with one of my coworkers, we were making a prosthetic arm for a girl in Cheyenne. So every day is kind of different. Obviously, we're not doing things like that every day. Some days I just show up and it's like, hey, Lando isn't working quite right. Go figure out what's wrong with him. And I'm like, you got it. So it's maintenance like that. And some days it's printing like 100 masks for the Cheyenne Regional Medical Center, which is what we've been doing lately. Every day is really different and they're all equally exciting. Right before all of this went down, my long-term project has been working on a life-sized version of R2-D2, which has been really exciting. I've learned a lot while doing that. Most notably that I'm not very good at connecting plastic to itself in the ways that you should, but it's been a lot of fun. It's just different challenges, different exciting things to do every single day. And that's probably my favorite part of working there. We actually do have a club. Our acronym is AWESOME, AWSM. It stands for the Association of Wyoming Student Makers. I like to flex about it whenever I can because it's really great. It lives up to its name. We're awesome. What we were doing before all of this was we're in the process of making an arcade machine, and I thought that'd be really cool. We'd like have it run on quarters, play a bunch of like classic games, just kind of to show off like what everybody brings to the table, because I'm really not great at programming or woodwork, but we've got carpenters and programmers, all sorts of people in the club who can do great things that I can't do. And I'm sure there's people out there who look at what I do and they're like, dang, I wish I could do that. And that's just really kind of the principle of the Makerspace, is a whole bunch of different people with different ideas and different skills getting together and working. A lot of people tend to think that you have to be an engineering student to work there, but that's really not true. Like I said, I'm a pharmacy major. So to join the Makerspace, it doesn't actually take very much. Really, all you have to do is show up and be like, I want to join the Makerspace. We give you a really quick safety training and then just teach you how to use any of the materials you want to use in the space. It's all totally free to learn. So if you just show up and you're like, I want to become a wood shop expert, we'll be like, okie dokie, point you to the direction of the wood shop, teach you how to use everything safely. Then all you got to do is basically just come back with your project, and that's just about it. If you're looking to get more involved, we have like volunteer programs, and then there's awesome as well. And eventually, potentially, there's paid positions that open up every now and again. So again, my name's Victoria Evans. Thank you for tuning in to Cowboy Coffee Hour. Stay Cowboy strong.